Hello, this is Shantia Meekum. I'm answering the video essay questions for chapters 18 and 19 for biology 2114. The first question is, discuss how the Frank-Starling law of the heart helps explain the influence of venous return on stroke volume. So according to the book, the Frank-Starling law is the relationship between preload and stroke volume. It states that the higher the preload, the higher the stroke volume. So preload is the degree to which cardiac muscle cells are stretched just prior to contracting. Stroke volume is the volume of blood expelled by one ventricle in one beat. And venous return means the amount of blood returning to the heart and distending the ventricle. So how does the venous return influence the stroke volume? An increased venous return will lead to an increased stroke volume. The venous return will increase in response to exercise or increased ventricular filling time, which is due to a low heart rate. The increased venous return leads to an increased preload, which leads to an increased stroke volume. The second question was, explain the reasons for the observed changes in blood flow velocity in the different regions of the circulation. What is the benefit of the different velocities of blood flow? Velocity means speed, and blood flow velocity is the greatest in the aorta and large arteries and slowest in the capillaries. Velocity has an inverse relationship with the cross-sectional area. If you think of a blood vessel as a tube, the cross-sectional area refers to the size of the tube, not the length, but like the diameter. Basically, a large tube that's 4 centimeters across will have a lower velocity than a small tube that's 2 centimeters across. Large tube equals low speed, small tube equals fast speed. This confused me at first because it seems like the capillaries should be faster than arteries since they are smaller tubes. However, the capillaries cross-sections are combined. The book gives the example of the aorta with a cross-sectional area of 2.5 centimeters squared. And the aorta has a high velocity of 40 to 50 centimeters per second. The capillaries combined cross-sectional area is 4,500 centimeters squared, which is much larger than the aorta's 2.5. And the velocity is going to be much lower. It's at about 0.03 centimeters per second. As opposed to the aorta's velocity of 40 to 50 centimeters per second. So the benefit of a low velocity is that it allows more time for exchange of nutrients and waste. So this occurs at the capillaries. So you want the capillaries to have a lower blood velocity to give more time for the cells to exchange nutrients and wastes with the blood.